Good day everyone! Welcome to Modern Physics channel. On this video, we will talk about special relativity. This is Leo Sinelio from BS in Science 3A. It's not just time is relative, it's length as well. As we found out, math tells us when we approach the speed of light, our measurement on space changes just like time. Length contraction is the phenomenon that a moving object's length is measured to be shorter than its proper length, which is the length as measured in the object's own rest frame. We have our equation. L represents as the length of measured from an observer outside frame of reference. LO is the length measured from an observer inside the frame of reference. We have the V of speed of the object and C is the speed of light. We have L is equal to LO square root of 1 minus V squared divided by C squared. Let's take a look on this example. Maureen Robinson is inside of the Jupiter 2 spaceship moving at 0.75 c, measures the ship as being 40 meters. John Robinson is on the Rust planet. How long does it look by John Robinson who is not on board by Jupiter 2 spaceship? First, let's identify the given values. We have the length measured from an observer inside the frame of reference, 40 meters. The speed of the object, 0.75 c. And the speed of light is equal to 3 times 10 raised to the power of 8 meter per second. And we are going to find the length measured from an observer outside the frame of reference. Let's substitute all the given values to the equation. Length measured from an observer outside the frame of reference is equal to 40 meter square root of 1 minus 0.75 c squared divided by c squared. 0.75 multiplied by 0.75 is equal to 0.5625. Cancel same units, which is c squared. We have now 1 minus 0.15625 is equal to 0.4375. The square root of 0.4375 is equal to 0.6614. 40 meter multiplied by 0.6614 is equal to 26.46 meters. Therefore, John Robinson, who is not on board by the Jupiter 2 spaceship, measured the spaceship as 26.46 meters. As we observe, the length of the spaceship has been contracted from 40 meter to 26.46 meter relative to the observer outside the frame of reference. Length contracted because of the speed of the spaceship, which is 75% light speed. Let's have problem number 2. Will Robinson wants to go after his mother. He used the Jupiter 3 spaceship, measures 45 meters, moving at 0.85 c. How long does it look by Will Robinson, who is on board by the Jupiter 3 spaceship? Let's now identify the given values. We have the length measured from an observer outside the frame of reference, 45 meters. The speed of the Jupiter 3 is equal to 0.85 c. And we are going to find the length measured from an observer inside the frame of the reference. We are now use the length contraction equation. We have 45 meter is equal to LO square root of 1 minus 0.85 c squared divided by c squared. 0.85 times 0.85 is equal to 0.7225 c squared. Cancel same units, which is c squared. 1 minus 0.7225 is equal to 0.2775. The square root of 0.2775 is equal to 0.52678. In order to get the value of length measured from an observer inside the frame of reference, we are going to divide both sides by 0.52678. Cancel both same numbers. And now, 45 meters divided by 0.52678 is equal to 85.42 meters. Therefore, Will Robinson, who is on board by Jupiter 3 spaceship, will measure 85.42 meters length. As we observe by the two problems, the length of an object varies by an observer, either outside of the reference frame or inside of the reference frame.